Okay, this video is going to show you how to give an exact answer for C without doing any rounding in between, which is, I think, what caused this problem or this answer to not be quite what was being looked for. Okay, so first of all, the slope of the secant line is this green dashed line. The red curve is f of x, square root, 8 times the square root of x plus 1. And so the slope of the secant line is the change in y over the change in x. And so there's an expression for the slope of that green dashed line. And here's a decimal approximation, 2.1916, which is where this is not quite as precise as was probably being looked for. The value of C is the slope of the tangent line that is the same as the slope of the secant line. And f prime is 4 over the square root of x, taking the derivative. And we want to know, when does that derivative equal the slope of the secant line? So I'll go to board 2 and show you how you might solve this to get an exact value. This will end up being C. Whoop. Okay, so on board 2, there's the equation we're trying to solve for x. If I cross multiply, I get 12 equals 8 radical x times this square root of 5 minus square root of 2. If I divide both sides by the coefficient of the square root of x, I get the square root of x equals 12 divided by 8 times that binomial. I reduce the 12/8 to 3/2, square both sides, which means we could have introduced an extraneous root, but we didn't. So if I square both sides, I get 9/4, and then squaring this binomial, get 5 minus double the product of the two terms in the binomial, plus square the second term. And this binomial simplifies to 7 minus 2 radical 10. Don't like the radical in the denominator, so let's multiply both numerator and denominator by the conjugate of that factor. The product of these two binomials is a difference of squares, so 49 minus 40 gives you 4 times 9 is 36. 9 goes into the 36 4 times, and there's your value of C. That's your exact value of C. There's your decimal approximation. So if we put that number into f prime, we should get the slope of the secant line. And there's f prime of C, 2.19. There was the slope of the secant line. Boom, it worked. Okay. Does f prime of C really equal the slope of the secant line as far as exact values go? So in other words, if I put this expression for C into f prime, can I make this side really look like this? Well, if we take the square root of the 4, 4 divided by 1/2 is 8. Let's try to eliminate the radical in the denominator by multiplying by square root of the conjugate. I get the square root of 49 minus 40. That's a 3. I get 8/3 times the square root of 7 minus 2 radical 10. So that looks sort of like this. The 8/3 matches. Does this expression really equal the square root of 5 minus the square root of 2? And these expressions are both positive. I think we can agree on that. So their respective squares should be equal. If I square the square root of 5 minus the square root of 2, I do get 7 minus 2 radical 10. So everything checks out. And there you go. So this is the C value between 2 and 5, where the slope of the secant line for this continuous function on the open interval from 2 to 5 is equal to the slope of the secant line joining the endpoints. There you go. Hope that helped. If you have any questions, post a comment.